So welcome everybody to this latest revision video on 162 Maths, and in this video we'll be looking at the numbers section of the Foundation Paper 3 of the AQA GCSE Maths Foundation Free Advanced Information. Now, as always, there'll be a copy of the questions that we go through in this video in the description below for you to have an attempt at, either while watching this video or prior to watching this video. And I'll also include the mark scheme so you can see what other answers are available that differ to the ones I'm doing on this video. So before we get started working through some revision questions, let's just have a look at the pre-information given about the number section on the Foundation Paper 3 for the GCSE Maths of 2022. So looking at this particular section, and again, it's really important, I stress this in all the other videos, that in maths questions, they don't have to be explicitly just involving one topic. They could be linked with other topics, not only in the same section, but in other sections of the exam paper. So for example, you could have a place value question that's linked to statistics or probability. So it's always worth just making sure that not only do you understand the topic, but also know how to use those particular topics in other areas. So going back to this, in terms of number property, now place values, what you need to do is make sure you know what the place values are. So what we mean by place values is looking at thousands, hundreds, tens, units, but also looking beyond the decimal point of looking at tenths, hundredths, thousands, etc. Now, one thing I would recommend that you do is know how to write place value using fractions. So for example, a tenth is 1 over 10. So 4 tenths, or 0.4, would be represented as 4 over 10. Hundredths would therefore just be 1 over 100. So if I had 0.23 and I had to represent the 3 as a fraction, then it would be 3 hundredths. So the answer there would be 3 over 100. Factors and multiples, again, factors are just recognizing, remember, you know the difference between the two. So a factor is a number that goes into a number without leaving a remainder, and a multiple is a number that appears in that numbers times tables, and that is also linked with highest common factor. So make sure that you know how to work out the highest common factor, either by using a factor tree or using your calculator even, to find the product of their primes, and then using a Venn diagram, etc. Error intervals, this involves upper and lower bounds. And again, with this being on paper 3, it could involve a problem solving question. So for example, it could be linked with area and perimeter and other areas as well. So let me just finish my writing bounds there. Indice calculations, so make sure you know the laws. Now with this being on the foundation paper, it's recognizing that when you are multiplying indices and the base numbers are the same, in other words the big numbers, then you add the powers. When you are dividing, you take away the powers, and when you've got brackets, that you multiply the powers. And again, with this being on paper 3, it could be a problem solving. You could have like someone's working that's wrong and you have to spot the mistake. Now, when it comes to money problems, this could be absolutely anything, and the range of marks could stem from either being 2 marks to 6 marks. So hopefully by practicing some money questions and working with this and making sure you show your working out and try and show as much working out with these, particularly as big mark questions, and using your calculator effectively. Uses of measure, now there aren't any questions on this particular video that cover units of measure, but basically what I will do is I'll include in the description below all the units of measure and the conversions that you need to know. So for example, converting units of length, so millimeters into kilometers and meters into millimeters, or meters into centimeters, looking at units of mass, kilograms into grams, and tons and stones and etc. And also you're looking at capacity units as well, so litres, millilitres, and just recognizing that any problems that you're looking at, make sure you're always converting the units. And again, that could be a multiple choice question, could be 1 mark question, or it could be involved in another area. So just be mindful that whenever you're working with units, regardless of what topic it is in maths, make sure that they are the same. Now, before we go over some revision questions on the topics previously mentioned, just a little reminder that you can download the question paper of the questions that we're going to go through in this video and have an attempt at them before watching this video or while going through it. So let's get started. So looking at question 1, which looks at place value, it says circle the value of the digit 5 in 256,934 rather. So looking at this, what you could do now, one tactic you could easily do in these particular questions is to first of all write the 5, which is what we're wanting, and then just change every other digit into a 0. So that then becomes 50,000, which is our last option. With question 2, it says circle the value of the digit 2 in this answer. So here, when I actually work it out, I get 520. And then if I then convert every other number that's not the 2 into a 0, that then becomes 20. With question 3, it says circle the value of the digit 9 in the number of 7.96 to 2. So here I highlight the 9. I can then convert all the other numbers into zeros. Now if I enter that on my calculator, particularly if it's a Casio calculator, so let me do just that. So if I enter 0.900, then press equals, and it automatically will convert it into a decimal form, a fraction for me. So I know then the answer is going to be 9/10, which I kind of knew anyway, but again, just showing you how you can potentially use your calculator if you do find that question tricky. So in question 4, it says circle the value of the digit 7 in this number. Well, that there's going to be 0.07, which is 7 hundredths. So it's going to be our last option. And then question 5, it says circle the value of the digit 3 in this number. So that's going to be again 0.03. So that's going to be 3 hundredths, which is our third option. Moving on to question 6, it says write down 2 numbers that are multiples of 3 and that multiply together to make 216. So here there is a couple of numbers you could go for. So here what you want to do is basically divide 216 by multiples of 3 and see if it gives you a whole number answer. So if I bring back the calculator and do 216 divided by 3, then straight away I know that 3 times 72. So I could have that as one possible set of answers. But there are others I could potentially use. So for example, I could do 216 divided by 6, because I know that's a multiple of 3. That's 36. So I could have 6 times 36. So those 2 numbers are possible answers. If I go for another one, I could go for 216. Let's see if it divides by 9. Yes, it does. So I could have 9 and 24. So let's use another colour for that. So 9 and 24 would work. And let's go for another one. So let's go for, I think there is only another one. So 216 divided by 12. And so 12 times 18. So that's another set of numbers I could use. So 12 and 18. So any combination of those 2 numbers would be absolutely fine. Well, in terms of the colours rather than any of those 2 numbers. Moving on to question 7, it says work out the highest common factor of 75 and 105. So again, if I get my calculator, let me show you how you can do this, which on this calculator you can do it. So here, if I do 75, press equals, then what you're looking for is the fact feature on your calculator. Now, if I press shift and fact, it comes up with 3 times 5 squared. So 75 equals 3 times 3 times 5. And then if I then do this, oh, it's actually 5 squared. So let me just get rid of that and change that. 4 or 5, of course it is. And then 105. And again, do exactly the same. So 105, press equals, then press shift and the fact button. So it's 3 times 5 times 7. So 3 times 5 times 7. I then circle the common primes. So 3 appears in both, 5 appears in both, and that's it. So the HCF is going to be 3 times 5, which is 15. Moving on to question 8, it says write down all the factors of 18. So again, I've got 1, 2, 3, 6, 9 and 18. Now you can write those numbers in any order, but as long as you've got this all 6, then that would be fine. You would lose a mark if you only wrote 5 of them. Then says work out the lowest common multiple of 12 and 15. So again, if I start with the 12 and the 15 times table, or you could do a Venn diagram question, but again, it's entirely up to you which one you want to use. So here, if I've got 12, 24, then I've got 36, then 48 and 60 and 72, and then with 15 I've got 15, 30, 45, 60. So 60 is the smallest number that appears in both, so then the lowest common multiple is going to be 60. Moving on to question 9, it says 4 positive whole numbers add up to 84. One of the numbers is a multiple of 17. The other 3 numbers are equal. So what I'm looking for here, if I do 84 and then minus the multiple of 17, so minus, let's put a blue box there. So here I've got 17. The next one is going to be 34. And again, all I need to do on this is just use the calculator and just do 17 equals and answer plus 17, press equals, and it'll just run through my numbers that are in the 17 times table. So here the next one therefore is going to be 68. Next one is 85, which is not going to work. So then what I then need to do is take this away, so 84 minus those numbers. And what I'm looking for is the answer being a multiple of 3, because I've got to divide by 3. So here 84 take away 17 gives me 67. That's not a multiple of 3, so it's not going to be that one. I've got 84 take away 34. That's not, that equals 50, so that's not going to work. 84 take away 51, which is 33. Now that is a multiple of 3, so 33 divided by 3 equals 11. So that means that one of the numbers, the multiple of 17 is 51, and the other numbers therefore are going to be 11. Moving on to question 10, it says which of these numbers has exactly 4 factors. So again, looking at the factors of 4, that's going to be 1, 2 and 4. 8 has got 1, 2, 4 and 8, so that is true. 12 is 1, 2, 3, 4, 6 and 12, so that's not going to work. And 16 is 1, 2, 4, 8 and 16, so the correct answer then is going to be 8. Then moving on to question 11, it says a competition took place in 1983. It takes place every 6 years. Circle the year in which it will also take place. Now for this I would use my calculator, and I'm going to type in 1983, which is a starting year, press equals, and then what I'm going to do is add 6 years to it. Now what I'm going to do is I'm going to keep pressing equals until one of these 4 numbers appears. And if I quickly just glance over and try and find it, and it's going to be 2049, so that's the one that I need to highlight. Then moving on to question 12, it says x is a positive integer, 35 divided by x is a positive integer, work out the 4 possible values of x. Now an integer is just basically a whole number, so not a decimal. So here, what numbers can you divide by 35 that leaves no remainder? So there's a couple of numbers you can have, and those numbers are going to be 1, 5, 7 and 35, and you can write those numbers in any particular order. Looking at question 13, it says circle the multiple of both 8 and 12. So what number appears in both the 8 times table and the 12 times table? And the answer you should have is 72. For question 14, it says list all the factors of 30. So I'm going to go straight into the answer box. So you should have 1, 2, 3, 5, 6, 10, 15 and 30. Now it does help writing them in order, and the reason for that is because you can do 1 times 30, 2 times 15, 3 times 10 and 5 times 6. Then moving on to question B, it says that a factor of 30 is chosen at random. What is the probability that it is a 2-digit number? Well, there's only 3 2-digit numbers, and there are 1, 2, 3, 4, 5, 6, 7, 8 possible factors. So then the answer then is 3 over 8. Moving on to question 15, it says circle the number that is not a multiple of 6. So you're looking for which of these numbers does not appear in the 6 times tables. And the correct answer you should have is 76. And again, if you're ever unsure, you can just simply type into your calculator and see which one gives you a decimal answer or fraction, depending on what calculator you've got. Question 16 says, which of these numbers is a multiple of 12? So which of these numbers appear in the 12 times table? And the correct answer you should have is 72. Then moving on to question 17, it says that work out the highest common factor of 15 and 20. So here 15 is going to be 3 times 5. And 20 is going to be 2 times 2 times 5. And so the correct answer we should have is 5. Then it says work out the lowest common multiple of 6 and 8. So what is the smallest number that appears in the 6 times table and the 8 times table? So again, now with it being worth 2 marks, you do need to state the times tables. Although the answer is quite obvious, going to be 24, it's still good practice to make sure that you are writing those times tables just so that it's just blatantly obvious. And only because it's worth 2 marks, if it was only worth 1, then just writing 24 would be absolutely fine. It might be a case if you did write 24, then that would be a mark. But if you wrote, let's say, I don't know, 48, then you would get 1 mark for writing 48 because it is a common multiple, but it's not the lowest. So just be mindful of that. Moving on to question 18, it says circle the highest common factor of 4x squared y and 8xy cubed. Now for this particular question, what you need to know is, although it uses algebra, you've got to use what your knowledge of what factors are. So for this, what we're looking for is the highest common factor of 4 and 8. So what's the biggest number that you can divide both 4 and 8 by? So here the answer is going to be 4. So that's what I'm looking for that. Then looking at the letters, you're looking for the smallest power. So what's the smallest power of x I've got? Well, it's going to be x. And what's the smallest power of y? Well, that's just going to be a single y. So then the answer then for the highest common factor of these two algebraic terms is going to be 4xy, which is our second option. Now, when it comes to the lowest common multiple, again, break it down. So here we've got the lowest common multiple of 4 and 8. So what's the smallest number that appears in the 4 times table and the 8 times table? Well, that's going to be 8. And then looking at this now, with the highest common factor, you're looking for the smallest power. Now we're looking for the biggest power. So here, what's the largest power of x we've got? Well, it's going to be x squared. And what's the largest power of y? Well, that's going to be y cubed. So this is the expression I'm looking for, which is our middle option. Moving on to question 19. So this is where we start moving on to error intervals. So it says the diagram shows results to the nearest percentage, which is really important, of a survey of 1,000 motorists. And it says work out the largest possible number of motorists who thought driverless cars were a good idea. So looking at this, what we're looking at is all these percentages have been rounded to the nearest percentage. So if I look at to nearest 1%, so if I divide that by 2, I get 0.5%. So this is going to be 20 plus or minus 0.5. So that's going to be 19.5 and 20.5. Now the inequalities do make a difference on this. Now I'm looking for the largest number that could be in this. So if I multiply both these numbers by 1,000, then what I'm going to get is 900 and... well, it's 20% I need to work out. So here, if I could, these are percentages actually. So I then need to multiply. So the largest is going to be 0.205 multiplied by 1,000, and that's going to give me 205. Now the problem with this is because of the inequality has got to be less than 205. So what's the biggest number that's less than 205? Well, it's going to be 204. Then moving on to question 20, it says the length of each side of a regular pentagon is 8.4 to 1 decimal place. Complete the error interval of this. So the error interval is basically wanting the upper and lower bound. So here I've got, it's been rounded to 1 decimal place. So if I do the 1 decimal place divided by 2, it gives me 0.05. So then all I'm going to do is add and subtract that to 8.4. So that's going to give me 8.35 as my lower limit, and my upper limit is going to be 8.45. It then says for B, complete the error interval for the perimeter. Now a pentagon has got 5 sides, and this is the smallest side it could be, so it's going to be 8.35 times 5, which if I type that into my calculator, I get an answer of 41.25. And if I then look at the maximum length, which is 8.45, and I multiply that by 5, I get an answer of 42.25. Then moving on to question 1. So this question is very, very similar to the previous one. It says that the length of a pipe is 6 meters. To the nearest meter, complete the error interval of the length of pipe. So again, to the nearest meter, I do 1 meter divided by 2. That gives me 0.5. So I'm going to do 6 plus or minus 0.5, which gives me 5.5 and 6.5. It then says that the length of a different pipe is 4 meters to the nearest meter. So from that, that's going to be somewhere between 3.5 and 4.5. And Ollie says that the total length of 2 pipes is 11 meters to the nearest meter. Give an example to show that he could be correct. So what I'm looking for is I'm looking for a number that when I double and round up to the nearest whole number, to the nearest meter, to the nearest unit, it rounds up to 11. So for example, a typical measurement I could have is 5.4. So if I double that, that then becomes 10.8. And this to the nearest meter equals 11. So as long as when you double the length that you've picked, as long as it's between, I would say, 10.5 and 11.5, inclusive of 10.5 but excluding 11.5, then it should round up to 11. Moving on to question 22, it says Paul won a race with a time of 71.3 seconds. His time t is to the nearest tenth of a second. Complete the error interval due to rounding. So here the nearest tenth is this number here, which is 0.1. So if I divide that by 2, I get 0.05. So if I do 71.3 plus or minus 0.05 on the calculator, I should have 71.25 and 71.35. Then moving on to question 23, it says a number x is 15.8 when rounded to 3 sig fig. Circle the correct error interval. And the one that you should highlight is the top right hand answer. Moving on to question 24, it says John is drawing a quadrilateral. The length of each side is 5.2 to 1 decimal place. Complete the error interval of one side. So here I've got 1 decimal place is 0.1. So if I divide that by 2, I get 0.05. So I'm going to do 5.2 plus or minus 0.05. And that gives me 5.15 and 5.25. It then says complete the error interval for the perimeter. Well, a quadrilateral has 4 sides. So I'm going to do the lowest length, which is 5.15 times 4. And if I type that into my calculator, which I'm going to do right now, so 5.15 times 4 gives me an answer of 20.6. And then if I then do 5.25 times 4, I should get an answer of 21. Then moving on to question 25, it says work out the cube root of all of these numbers. Now for this, I would say with it being on a calculator paper, you can just simply type it in. Now just make sure that when you are typing this into your calculator, that you are copying it exactly what it is. So here I've got to do the cube root. So if I press shift in that, that's when the cube comes up and I set up my fraction. I then got 2 to the power of 7, and that's going to be multiplied by 11 cubed. And then scroll down to 2, press equals, and it comes up with an answer of 44. Now you would probably get 2 marks for that, but again, what you could do is if you want to show some working out is you could break that up. So if I get the calculator back, so if I do 2 to the power of 7 times 11 cubed, press equals, oh, got math error there, don't know what happened there, so let's do that again. So I've got 2 to the power of 7 multiplied by 11 cubed, press equals, it gives me 170,368 divided by 2, and then do the cube root of all of that. It should again give me 44. So moving on to question 26, it says work out the value of this. And again, I could easily type this into my calculator, but seeing as it's worth 3 marks, now I personally think this is a non-calculator question, but let's just go through it. So here, 3 to the power of 12 divided by 3 to the power of 5. Well, when we're dividing, we take away the powers. So that's going to be 3 to the power of 12, take away 5, which is 7. And then I've got a dividing. And then if I then look at this bracket, well, that's 3 to the power of 1, so it's going to be just 3. And then I take away the powers, so it's going to be 3 to the power of 6. Actually, no, it's not. It's going to be 3 to the power of... Oh, that should be a 3 there. Apologies. 3 to the power of 4. So then from this next one, question 27, here we've got brackets. Now remember, when you've got brackets, you multiply the powers. So it's 5 to the power of 4 times 2, which is 8. So it's going to be our second option. Then looking at question 28, so here we're comparing coefficients. So what you need to look at here is when I expand this out, so let me just write this out again, so in case it's difficult for you to see, which I've already written it wrong, so let me just correct that. So it should be A or B to the power of 4. Well, that's going to be A to the power of 4 or to the 4B, because again, I multiply the powers by when they've got brackets. So what that means is that 16 has got to be equal to A to the power of 4. So A to the power of 4 equals 16. So if I do the quart root of 16, that then gives me 2. So A equals 2. Then for the next one, I've got 20 must equal the same power. So I've got that 20, or 4B equals 20. So if I take the 4 by dividing by 4, I end up with B equals 5. Moving on to question 29, we've got simplify x to the power of 5 and 2. So here we multiply out the powers, in which you should have x to the power of 10. Then looking at question 30, it says Chris is simplifying 3n 5 times 2n to the power of 4, and his answer is 5n to the 20. Identify any mistakes he has made. Well, he's made 2 mistakes. His first mistake is that 3 times 2 is 6, not 5. So that's his first mistake. And the second mistake he's made is that he's multiplied the power. So Chris has multiplied the powers instead of adding them. So in other words, n to the power of 5 times n to the power of 4 should be n to the power of 9, not n to the power of 20. So something along those lines would be absolutely fine. And then moving on to question 31. So again, let me just rewrite this question just in case it's coming a bit blurry on the screen. So it's a to the power of 4 times a to the power of 6 divided by a to the power of 3. Now with this, looking at the numerator, I'm multiplying, so I add the powers, so that then becomes a to the power of 10. And then I'm dividing, so I take away the powers. That should be, a 3, not a 7. And so that then gives me a to the power of 7, which is my first option. So then moving on to question 32, it says Eva writes 4 squared times 4 squared times 4 squared as 4 to the power of 2 times 2 times 2, which gives us 4 to the power of 8. And the question is asking is what is wrong with her method? Now here, all we need to do is just recognize that when you're multiplying with indices, you need to add the powers when the base numbers are the same, and Eva has multiplied. So that's all we just need to write. So Eva has multiplied instead of adding. Now sometimes when you are correcting someone's mistake, you can answer the question by writing down the correct method or the correct answer they should have. So here it should be 4 to the power of 2 plus 2 plus 2, which is 4 to the power of 6. Or you could just use it to emphasize what you have stated. Not sure why they've written an answer box here, but there we are. Moving on to question 33. So let me just rewrite this question just in case it's a bit difficult to see. So it's 3 cubed times 3 to the power of 4, all divided by w to the power of 2. Notice I didn't say w in the first one. So here, looking at this, we're multiplying, so we add the powers. So that's w to the power of 7 over w to the power of 2, and then we take away the powers, so it becomes w to the power of 5. Then moving on to question B, it says simplify fully. So here we're multiplying everything by everything. So looking at the numbers, 2 times 4 is 8. Then we've got x squared times x. Now that's x to the power of 1. So we add the powers. So that's going to be x to the power of 3. And then we look at the y. So I've got y cubed times y squared, which gives me y to the power of 5. Then when it comes to C, here we're simplifying with dividing. So what you want to do is recognize that here we can split this up. Now this is the same as 12, a to the power of 4, b to the power of 5, all divided by 2, a squared b. Now with this, what we can do is we can split things up separately. So we can do 12 divided by 2 times a to the power of 4 divided by a squared times b to the power of 5 over b. So what we've got is got numerators, denominators, all of the same type. So in the first one we've got numbers, second one we've got a's, third one we've got b's. So from this we can then simplify them separately. So 12 divided by 2 is 6. A to the power of 4 divided by a squared is a squared. And b to the power of 5 divided by b to the power of 1 is b to the power of 4. Moving on to question 34. So again, we've got these indice questions, so indice calculations. So here we've got a to the power of 20 times a to the power of 5. So we add the powers. That's going to be a to the power of 25. Here we're taking away, so that's going to be a to the power of 15. And then with brackets, we multiply. So it's going to be a to the power of 20 times 5, which is 100. Moving on to question 35, it says that Harry will pay income tax if he earns more than £12,500 in a year. After 8 months, he has earned a total of £7,600. For the rest of the year, he earns £1,200 each month. Will he pay income tax? So for this, what we need to do is we need to work out how much he earns over the year. So here we know that he gets paid for the first 8 months, he gets £7,600. So that's for 8 months. Plus, and then he gets paid £120 each month. Well, how many months are left? Well, it's going to be 4 months left. So it's going to be 4 times 120, 1020 rather. So then from this, I can then type that all into my calculator and let's see what we get. So here we're going to get 12,400. So is that more than 12,500? No, it isn't. So no, Harry will not pay tax. Lucky boy. And then as 12,400 is less than 12,500. Moving on to question 36, it says members of a club are either senior, adult or junior. Here is a report about the members of the club. Give a reason why there must be a mistake in the report. Now this one, what you should notice is that if I add up each of these percentages, they don't actually add up to 100. They actually add up to 110. So here all we need to write is that the percentages do not add up to 100%. It then says that an adult membership is £120. A junior membership fee is 1/5 of the adult fee. Work out the total membership of 2 adults and 3 juniors. So first of all, let's work out what the junior membership costs. So that's going to be 1/5. Now of means multiply. So if I do 1/5 of 100, and again type that into my calculator, I get an answer of £24. So then working out what 2 adults are. So 2 adults is going to be 120 times 2, which is 240. And then if I do 3 juniors, that's going to be 24 times 3, which is 72. And then if I just simply add those 2 amounts up together, I get an answer of 312. Moving on to question 37, it says Jenny works 30 hours as a pair and is paid £318. Calvin works for 28 hours and paid £287. And it says Jenny is paid more per hour than Calvin. How much more So what we need to do is work out the daily rate. So for this, we need to divide the amount they're getting paid divided by the number of hours. So this is going to be 30. So Jenny is going to earn £10.60 per hour. And then we do the same calculation for Calvin. So 287 divided by 28. And that gives us an answer of £10.25 per hour. So from this, Jenny is paid more. How much more? So we then just need to work out the difference. So £10.60 minus £10.25 gives me an answer of 0.35. So then it's going to be 35 pence. Moving on to question 38, it says that a shop has this offer: £5 reduction if you spend more than £100, £10 reduction if you spend more than £150, and £20 reduction if you spend more than £200. At a shop, the dresses cost £42 each. Amira buys 3 dresses, Bobby buys 5 dresses. How much more than Amira does Bobby pay? So let's have a look at how much each of them pay. So looking at Amira, so Amira is going to buy 3 dresses, so that's going to be 3 times 42, and 3 times 42 is £126. Now from this, because she's spending £126, that means she qualifies for a £5 reduction. So if I take away £5, then Amira is then going to pay £121. Then if I look at Bobby, so Bobby buys 5 dresses, so we do 5 times 42, and that comes up to a total of 210. Now Bobby then qualifies for a £20 reduction. So if I take away £20, she ends up paying, or they end up paying, I should say, £190. So then all I then need to do is work out the difference between the two. So the difference is going to be 190 minus 121, which gives me an answer of £69. Then moving on to question 39, it says that Lucy works 37 hours per week. Her weekly wage is £303.40. She receives a pay increase of 25 pence per hour. Work out her new weekly wage. So a couple of bits of information here. So we've got 37 hours per week. Weekly wage is £303.40, and we're doing a 25% increase. So a 25 pence increase, I should say. So looking at this, let's have a look at what she is paid per hour. So per hour, it's going to be £303.40 divided by 37. And if I type that into my calculator, she gets paid £8.20 per hour. Now what I then need to do is add 25 pence to this. So she's going to get paid, so new hourly wage is going to be £8.45 per hour. She then works, so a daily wage is going to be, oh no, weekly wage, I should say. Is going to be a number of hours, which is 37, times her wage, which is 8.45. And if I type that all into my calculator, I get an answer of £312.65. Then moving on to our last question, it says that John has 78 pence and Nat has £3.52. Nat gives John some money so that they both have the same amount. How much does Nat give John? Now this question is incredibly popular with all the exam papers that I've done in the past. So here what we need to do is work out, first of all, what is the total amount. So here the total amount is 0.78, and it's always important that you make sure that you're using the same units, plus £3.52, and that comes up to a total of £4.30. So then if we share the amount equally, so share equally, then we get £4.30 divided by 2, which equals £2.15. So now they've got £2.15 each. So then if I then do £3.52, which is how much Nat has, deduct it from what they now have now, I get an answer of 1.37. So how much has Nat given John? It's going to be £1.37. And that concludes the end of this revision mix sheet.